Howdy, howdy. This is Mr. Potter. We're continuing our exploration of the PictureLab from Java, the one that's done by Barbara Erickson from Georgia Tech. So I've opened up three files here. I've got the simple picture.java. I've got picture.java, which actually extends simple picture, and then I've got this picture tester. So I want to take a look at one particular method in simple picture.java, and it's this get pixels 2D. We saw that when we were exploring pictures in our last video that we were looking at rows and columns of pixels, individual pixels, and our picture explorer allowed us to click on a particular pixel and extract the red, green, and blue information from it. So what we're doing here is we have a method that will get a two-dimensional array of pixels from this picture, and it's going to be doing it in row major order, which means it's doing row by row, column by column. And so what this does is this creates an array of pixels. This is actually a two-dimensional array with the height given by the number. The height is rows for us, so that comes first, and width is columns, so that comes last. And that's something you do have to be aware of when you're dealing with pictures, because in our math classes we typically deal with x and y, where x comes first and our y comes second. So when I talk about the 0.3, 4, I'm talking about going over 3 positions, then up 4 positions to get to that coordinate 3, 4. But if I say I'm on the third row in the fourth column, I have to start at the top and work my way down 3 rows, and then move myself to the right 4 columns. So the directions are not only exchanged, where we're doing height first, then horizontal position, but our y values, our rows, start at 0 at the top and work our way down. So what this is doing, this get pixels 2D, is it's actually setting up an array where the height is the number of rows that we have, because that's a top-down view of the picture, and the width is the number of columns we have. And so what we're doing is we loop through. We've got row 0, row less than height, row plus plus, col is 0, col less than width, col plus plus, and the particular row and column is equal to the pixel at the picture column, comma, row. So keep in mind, this is my x coordinate, how far over, or how many columns over we need to move, and my y position, how many rows down we need to move. And this isn't necessarily intuitive because a lot of people get this uh, exchange between rows and columns and X and Y confused. For the pixel array, we're dealing in rows and columns, but this pixel really is a X position and a Y position. And then, of course, we returned the pixel array. This is important because for one of the things that we're going to be looking at is this zero blue method. What this does is this actually gets the two-dimensional array of pixels from the simple picture method. And then it goes through row by row, column by column, and sets the blue at every pixel to 0. Notice we talked about the pixel class in our last video, and we had accessors and mutators for each of our three colors, red, green, and blue. What this does is this basically sets our blue to a 0 value. So this essentially eliminates the blue. It's going to shut the blue down all the way to 0. And we're doing this using foreach loops. So what I'm doing is I'm getting an entire row of pixels, which would be a pixel array from pixels. And then in that row, I'm getting each individual column of pixels. So this is row and column. But I've got one pixel, and remember that the pixel keeps track of its X coordinate and its Y coordinate, as well as its R, G, and B components. And so I'm essentially setting its blue component to 0. So if I go to Picture Tester, and this is a main method that actually has a lot of different methods that we're going to need to write, and we're going to write 2 of them today. It's all it's doing is calling on test 0 blue, and if I scroll up here, I'm going to see what test 0 blue test 0 blue. What this does is this loads the beach picture that we did last time. It's going to call on an explorer, and then it's going to call on the 0 blue method, which will eliminate all the blue, and then we'll be able to explore it again. So if I run this, I see that it opens up to explorers. This was the first one over here, and notice that there is lots of blue over here, as well as the yellow and the green. And we explored this. I can see the blue composite amount here. Like there's my blues 230. Here my blue is 155. If I go over to this image where we've removed all of the blue, notice that I've got greens and yellows, and we remarked upon the fact that when you take green light and red light and add it together, you get yellow light. So these things are very, very yellowish. They're very greenish tinge. There's no blue really to be seen. Even though this kind of looks blue, it's actually a very strong green color here. Green is 146. Our blue component is 0. For every pixel in this illustration, our blue component is going to be 0. So what this does is this eliminates all of the blue in a picture. I want to take this and I want to modify it a little bit. So I'm going to go back to this picture class, and I want to write a method that's going to essentially eliminate all of the other colors. So I've got a method here that in our thing that says keep only blue. So I want to take a look at what keep only blue would be like. So we'll say public static void keep only blue. And so what's going to happen is this is going to call on keep only blue. I'm going to need to go through our picture array. So I'm going to have to create an array of pixels. And this is going to be actually a matrix of pixels. Gets, and I need to call on this dot, and I need to get the two-dimensional pixel array. There's this get pixels 2D method in our simple picture class. And because we are extending it, I never actually showed this. Let me scroll up to the top real quick. We can see that we are extending simple picture. We do have access to all of this. All of the methods in simple picture we have direct access to. So I can say this dot, what was it called again? Get pixels 2D. Get pixels 2D. And so this is going to get a two-dimensional matrix of pixels, which I can then go through using a foreach loop. So I'm going to say for, and I'm going to have a pixel array, which I'll call row, in what did I call this? I never actually called this. Let's call this pixels. So I'm creating an array of a row of pixels from each row of the pixels matrix. And then in here, what I'm going to do is I'm going to say for pixel P in row. And what I want to do for this is I want to take P, and since I'm keeping only the blue, I really want to eliminate the red, and I want to eliminate the green. So for this pixel, I'm going to do P dot set red to 0. And I want to do p dot set green to 0. And so this is going to set p dot set red and p dot set green. All of these are going to be set to 0. I'm going to compile this. Hopefully I don't have any major mistakes. Okay, so the issue here is I shouldn't have static here. That's the problem that we're having. That should compile now fine. And now if I go to picture texture and I comment out, or actually I uncomment test keep only blue. Do I have test keep only blue written up here? I don't have that method up here, but I actually want to just kind of copy what I've got here. So I'm going to copy this. Copy all of this. We're going to write a method here. This is going to test keep only blue. So I'm going to say keep only blue. And now if we run this, as soon as I call this test keep only blue, test keep only blue, we'll run this. And so keep in mind, we've got 4 things here. This is where we're keeping only the blue. And you can see everything here is blue. And that certainly makes a difference from this picture here, which has all of the blue removed. Notice that in the positions where I have the shadow, basically I've got, no color here. If I take a look at these, I see that my red and my green components are completely gone, and my blue component is just a full intensity or shadow. I have really low blues. So this is pretty much what we expect. And if I were to take these two pictures and add them together, add the green and red components with the blue components, I would end up back with my original picture. Notice the blue is the strongest blue up here in the sky area, because that's where the blue is the lightest over here. Down here I'm expecting not to see very much blue, and so the blue values are actually fairly low, especially in the shadows, though, or where I'm going to see the lowest blue. So there's one other thing that I want to talk about. I want to actually close these windows, but take a look at this, because this almost looks like a black and white picture. And you may remember in our previous video that we talked about whenever we have uh, something on that gray scale that our red, our green, and our blue components all had to be the same. And so it makes me wonder, what if I was to set my red and my green components to this blue component value? I would end up with something that looks like a black and white picture. And so we're going to go ahead and do that. Actually, we're going to do that slightly different. What I'm going to do is, this method is called grayscale. So we're going to create public void grayscale. And so again, as before, we're going to get a matrix of pixels. So pixel array matrix pixels gets this dot get pixels 2D. And open close parentheses. And then for, again, I want to go row by row. So I'm going to create an array of pixels. So pixel array row in pixels. And of course, the reason I'm doing this is that I don't have to get pixel dot length and go through from the beginning to the end and treat these as numbers, because it's going to be much easier for me to directly access this through the list here. So for pixel p in row, and then I want to do the following. I want to say p. I'm going to say int blue val gets p dot get red. Remember that we have accessors for all of these things in our pixel, and I can say p dot set. Why do I want to get red? I want to get blue. We're actually going to change that in just a moment. I'll explain why. I want to p dot set red to my blue val, and I want to do p dot set green to my blue val. And so what this is going to do is it's going to get whatever my blue value is and set the red and green appropriately, so that our red, green, and blue will all be equal to whatever our blue was before. So let's compile this. And silliness, get pixels 2D. Really would be nice if I could spell. Now we're going to go to our picture tester. We're going to comment out this grayscale. And we're going to copy this method here, and we're going to call this test grayscale. So we're going to copy this. We're going to paste it. So this is a method to test grayscale. So we're going to call this test grayscale. And we're going to call on the grayscale method. Did I spell that the same? Grayscale. So it needs to be a capital S. All right, so I should be able to run this. Nope, what did I do wrong? Test grayscale. Oh. I always do that. I always spell with the E instead of that. That should work fine though. Let's go ahead and shut off our programs and run this again. And so here I see a grayscale image of this. Now, this isn't a very good grayscale, and the reason is because the human eye is much more sensitive to green than it is to blue or red. It comes from our simian ancestry. We need to be able to see leafy foliage, and especially hostile animals that are going to hunt us down. So I really want to make this so that we extract the green quality and put it in those two things. So I actually want to go back to my picture class, and I actually want to have this be the green value, and I want to get this out of p.getGreen, and then I want to set red using the green value and set blue using the green value. So we're going to compile this and run this again. And of course, it's going to show all these pictures. And this actually looks a little bit better. Notice that we see a lot more detail here in these leaves, which we didn't see before. And I really wish I could have left that up here to kind of show you what that looks like. But we actually get to see a lot of the detail here. The green actually tends to work out much better for a grayscale. Now, notice, of course, anywhere I click, all of my red, green, and blue components are all the same. Okay. So, I want to try one other image manipulation. So let's go down here and see what we have to test. So we did test 0 blue, which looked good. So let's go ahead and comment that out. We did test keep only blue, which looked good. And we had this test grayscale. So the only thing we have left is this test negate. And if you've ever looked at a photo negative, notice what happens is that our blacks look white and our whites look black. And of course, the idea is that we're going to kind of negate the color. In other words, make it the opposite of what it is. And the way we're going to do that is by taking a look at the red, green, and blue components and dealing with the number 255. Remember that our red, green, and blue components are on a scale from 0 to 255. So if my red component was 50, then in the negative I should be the opposite of 50, or 255 minus 50. So what I'm going to do for this public void negative is I'm going to create a pixel matrix, just like I've done before, called pixels. Gets this dot get pixels 2D. And for I don't know why I'm doing braces here. I don't need to. So for pixel array row in pixels, and then for pixel p in that row, we're going to do the following. We're going to p dot set red to 255 minus p dot get red. In other words, I'm going to get whatever my red color is, and then I'm going to take 255, take that from 255, and then set my red to that new color. I'm going to do the exact same thing for green. P dot set green 255 minus p dot get green. I'm going to do the same thing for blue. So p dot set blue 255 minus, let's change that to a minus right now before it tells me it's wrong, p dot get blue. And so this is going to be my negative of my image. So let me compile this, make sure it works well. Excellent. And what we're going to do is we're going to test negate, and we're going to copy this code essentially. And so we're going to test negative. So it's test negate. But what I want to do is I want to get the negative from my picture. So we're going to go ahead and run this. And so what I see here, let's not change the size. is I see my original picture, but then I also see this photo negative aspect of it. In other words, over here, where I have something that's very bright, I actually have something over here that's fairly dark. And notice that these numbers really do add up to almost 255. I mean, I'm not in the exact same row and column, but I've got 230 plus 25. I've got 204 plus 51. My red's just a little screwy at 167 and 91. That's only that's 258. But if I go to what's dark over here, like these shadows, I actually end up with something that's fairly light over here. So here I've got 6, 8, and 5. Here I've got 253, 251, 255 for all practical purposes. This is white. And so what I've got here is I've got a photo negative version of this. Notice that this is very, very heavy with the greens and blues, and if I click over here, I end up with this very, very nice mauve color, this pink. So notice I'm very heavy with reds, not so much heavy with the greens and the blues. Notice that my mountain is fairly gray, and so over here this should still be fairly gray, but not this reddish green tinted gray, but actually kind of, I mean, there's not this bluish green tinted gray, but more of a reddish tinted gray. Down here I've got the sand, with sand has very, very high red and green values and relatively low blue values. And over here I'm going to have relatively high blue values compared to my red and green values. So the idea here is that we can go through the pixels in a picture, row by row, column by column, and manipulate them as we need to. So we can actually change the red components, green components, blue components. We can get those components. We can set them to 0. We can change them to their opposite. We can mix and match them however we want to get some pretty interesting effects in our pictures. And that's really kind of the focus of today's lesson, using this picture tester to allow us to manipulate the colors in a picture. So once again, this is Mr. Potter. Thank you for watching. Have a great day.